Okay, so P6.5, specific latent heat. So last lesson we were talking about latent heat, and I said that that was how much energy is required to change state, and which state you're changing to will be different amounts of energy. Specific latent heat is a bit more specific. So it wants to say how much energy is needed to change state per kilogram of mass. So that's the difference. Latent heat is just how much energy is needed to change state. Specific latent heat is specifically how much energy does it need to change state by 1 kilogram. To change the state of a kilogram, okay, per kilogram. And if you wanted to work out what the specific latent heat of fusion, so that's turning from a liquid to a solid or from a solid to a liquid, then you need to do the energy divided by the mass. Okay. So if you wanted to melt it, you have to put energy in. If you freeze it, it gives off energy. And then if you wanted to do the specific latent heat of vaporization, then it's the same thing. It just has a V next to it, and this one has an F next to it. That's the only difference. It's just this bit here. Everything else is the same, and then it's energy divided by mass again. And this time it would be, if you wanted to heat a liquid up to vaporize it, that would be the energy it needs to put in to turn it into a gas. And equally, if you want to do it from a gas to a liquid, that's the amount of energy that's given off. It's why steam burns are so bad for you, because if you put your hand in steam, not only do you have the high temperature of the steam, but you also have the latent heat being released when it changes from a gas to a liquid. Okay, and the other thing that we need to know is we need to know how to measure these two things. So let's talk about how to measure the latent heat of fusion first. So if I've got some ice in a funnel and I measure the mass of the ice to start with, then I give it 10 min and I measure the new mass. So that'll be the mass lost. Okay, so that gives me how to measure the mass to start with, wait 10 minutes, then I can work out how much mass is lost, and that mass lost will be how much is turned into a liquid. Okay, then the next thing I want to do is I then want to add a heater into my liquid, and I want to use an electric heater for the same reason when we're doing specific heat capacity. I want to use an electric heater, and that's because I can quite easily work out the amount of energy that I've supplied to my heater by using the voltage and the amount of time. So if I know that the voltage equals energy per unit charge, then I can work out and power equals IV, which equals energy over time. I can work out how much energy I've given my circuit by doing P equals TIV. So that's going to be energy, sorry. Because all I've done is times the IV by time. So time times by current times by voltage will give me how much energy I've put into the circuit. After I've put in a known amount of energy, I can measure the mass again, and this time I can see how much mass have I lost due to my heating. but that's not going to be the mass that I've lost. So the mass lost due to the heating will be equal to the total mass lost minus the mass lost with no heating. So what you're saying is, first of all do it without a heater for 10 minutes, measure the amount of mass that's lost. Then start again with exactly the same amount of mass, but this time with the heater, and this time measure how much mass is lost. So that's all of it this time, but if you want to know how much is lost due to the heater alone, then you need to do the total mass lost with the heater on, minus the mass lost when the heater wasn't on, and that will tell you how much mass was lost due to the heater. And then if you know that, then you can put that into your equation up here, because you know that your energy was the amount of energy that you supplied using your voltmeter and ammeter, and the amount of time that you've been given it energy for. You know your mass because it's the amount of mass lost purely due to the heater, not just what melted because the room was warm. That was what was melted because the room was warm, and you got rid of that when you took it off here. Okay, that's that method. That's the harder one. The easier one is exactly the same situation. If you wanted to measure the specific latent heat of vaporization, you this time put the heater into the water. Exactly the same thing. It's going to be another electrical one. So energy is going to equal IV times T again. So you know how much energy you've put into your heater. You've got your liquid. You measure your mass to start with, and then you measure your mass afterwards. And the difference in mass you can then put into the equation up here. Energy divided by mass, that will tell you what your vaporization should have been.